Question number 1. Gallup poll interviews 1,600 people. Of these, 18% say that they jog regularly. A news report adds, the poll had a margin of error of plus or minus 3 percentage points. You can safely conclude which of the following. All right, so the important information here is our sample size, the point estimate or the sample proportion, and then the margin of error, 3 percentage points. All right, so I'm just going to make a note of these things over here to the side. So sample size, 1,600, sample proportion, 18%, margin of error, 3%. Okay, so this is what we know. All right, so let's read through the 5 choices and find the best one. Choice A, 95% of all Gallup poll samples, like this one, will give answers within plus or minus 3% of the true population value. B, the percent of the population who jog is certain to be between 15 and 21%. All right, so I'm going to go ahead and eliminate B right now. And the reason is because this is a statement of certainty, and we don't make those, we only make, confidence statements like, oh, I'm 95% confident or 99% confident. We never say that we're certain. We're never guaranteeing anything. All right, choice C. 95% of the population jog between 15 and 21% of the time. All right, so this is another one that I feel we can eliminate because the percentage here it doesn't represent a proportion or anything like that. It represents a level of confidence, right? So we want to say something like, we're 95% confident that the interval from 15 to 21% captures the true proportion of people who jog. Okay. All right, D says we can be 3% confident that the sample result is true. Okay, so 3%, that was the margin of error. It's not the level of confidence, so that was completely misinterpreted. E, if Gallup took many samples, 95% of them would find that 18% of the people in the sample jog. Okay. So at this point, A and E seem like very similar statements. Okay. Now I'm going to bring this image in here, right, so we can visualize, what happens when we take many samples and we create an interval for each one. Okay. Now, some of the intervals will hit the target, meaning they'll capture the true proportion, but some of the intervals will miss. Okay. Now, in the long run, right, in this case, 95% of the intervals should capture the true value, right? So like 1, 2, 3, right? The 4 that you see there captured, and then 2 missed. Okay, but there's a lot of other intervals that we're not seeing, right? So think about thousands of intervals that were created. 95% of them would capture the true proportion. Right. So I wish that was one of the choices. I got to figure out which is the closest to that. Right? 95% of all intervals will capture the true proportion of people who jog. Just add in the context. Okay. Now here's the thing. The true proportion of people who jog, we don't know what that value is, right? It's not 50%. I just grabbed this image from one of our activities, right? That green line there, right, represents the true proportion, but we don't know its value. Okay, which means that statement E can't be correct, right? Statement E is kind of inferring that 18% is the true proportion, but it's not, right? 18% is like just one of these dots here, right? Right, it's one sample that gave a result of 18%, but it's not the true proportion. All right, so now that E is eliminated, A is going to be the best choice here. Okay. Now, when it says that it gives an answer within plus or minus 3%, right, it's saying that, this dot is within 3 percentage points of the truth. Well, for these black intervals, that is true, right? each of these black dots would be within, 3% of the truth. But these red dots would be more than 3%, right? If we think about the width of the interval as being plus or minus 3, I should label it here, right? So think of that as being 3% above the point estimate. Think of that as representing 3% below the point estimate. Right? All of the black dots are within 3%. All of the red dots are more than 3% away from the true proportion.